Greetings, grade 12s. Welcome to Technical Mathematics. Today is the 2nd of October. Then we are going to be dealing with application calculus. That is the topic that we are going to be discussing for today's lesson. And then as we are preparing ourselves for this coming final exam, let us make sure, especially for this one, because now we realize that our learners, they've got a serious challenge when it comes to application of calculus. Now, through this lesson, please listen attentively and then try to get some questions similar to what we are going to be doing for today's lesson, and try to understand what is really needed from you to understand this the application of calculus. Is very important topic, please. And then the other issue is issue of examination guideline as well. I always repeat that. I always advise learners to have that document. It's very important. And then it also outlines the important information that you have to know for each topic under technical mathematics. So let us make sure that we do have all those things. And then even previous question papers, they're very important. And then we should also revise with those. And then we can also have these videos as well. So that it can help you to prepare for the coming final examination. And then let's start our lesson and see what we are going to be discussing for today. And then under content, we have differential calculus and the integration. And then we'll be focusing only on application of differential calculus. And then the other one is the integration. So those are two topics that we are going to be discussing for today's lesson. So let us make sure that we understand around the application of calculus and also the integration. All right, now let's see what are we going to be getting. All right, now application of calculus, the steps to solve maxima and the minima problems. Let's understand, can we do this to be maximized or minimized? And then the second point there, it says draw a diagram if possible. And then if there are two variables, eliminate one using the given information and simultaneous equation. Write down f of x and f prime of x. And another point says they set the derivative equal to 0 for maxima or minimum. So in fact, if you are looking for maxima value or the minima, then you have to equate the equation to 0, but after we have derived it. So we have to equate it to 0. Now, in order to maximum or minimum an object, for instance, f of x, now you should now determine f prime of x, meaning this is the derivative of what? Of f of x. Then thereafter you then equate it to 0 so that you can solve the value of x. So it will depend on the variables that we are working with. It's not always the case that you have to solve for x, right? Hence I'm saying it depends on the variables that we are having. So, but it's very important every time when you are answering your question under application of calculus, when it says calculate the value of any variables to get the maxima or the minima, you must know that you have to derive that particular equation, and then thereafter you equate it to 0. Then you solve whatever the variables we have on that equation. All right, and then let's see questions that you might get final examination. Right, let's see this scenario and see on how do we answer the questions. And then a manufacturer has designed a box of which base has the width equals to x. Now the width is equals to x centimeter as indicated below. You can see that this is is twice the width. Width. Now the first question says write down the expression of the height. Every time when you are reading a scenario from the question of application of calculus, whatever which is given from the scenario, you are going to be using that in order to answer the first question. For instance, you can see from this scenario, you are given the surface area of the box, which is 120 centimeters square. Now, for you to be able to answer the first question or to address the first question, you have to start writing the surface area. That is the first step that we have to do, right? Now, let's see how do we do that, determine the surface area. You then write the formula for surface area. Now you will realize in this formula, for us to be able to answer the question, you can see that it says write down the expression of the height. Now, meaning if we had to write this in terms of the height, then we have to make h the subject of the formula. So it's going to be in terms of x. So we're going to substitute everything that we are having there after we make h, which is the height, the subject of the formula. Then we will be answering that question. And then the second step, of course, we're going to be substituting. Then it says we have the surface area, which is 120, and then this is 2, which is w is width, which is x. You can see this is x. L, we agree that L is twice what? Twice the width, which is 2x. And then of course h is there, it's still the same. And then we have the length is 2x, h plus h is h, and then w is the width, which is x. Then you multiply, then this is what we're going to be getting after multiplying. Now remember, you're going to multiply. This one is going to give us 2x squared, and then here is going to give us 3xh, which is this one. Now what happened with these two outside? We divide with it both sides, and then when you say 120 divided by 2, it will give you 60 there. This is what we're having. That because now we want to make the y, the h the subject, then we're going to be transposing this 2x squared to this side. Hence you see negative 2x squared there. Then we divide both sides with 3x. Then that's what we're having. So that is the first one. And then the second question says, show that the volume of the box is given by this. We have to prove this now, the volume of that. Now, how do we do that there? So instead of h, now you are going to be substituting with 60 minus 2x squared over 3x. Then you just multiply. You can see this x, it can cancel 2x multiplied by negative 2x squared, it gives us 4 minus 4x cubed over 3. So this is the volume that we are having. And then from there we simplify it, then it's going to give us 40x minus 4 over 3x cubed. So that is what we were supposed to to prove or to show. That is that. Let's proceed. We are having the same scenario, the same question. All right, now we're having a new question there that says determine the values of x for which the volume of the box will be maxima. Then I said we are going to be deriving the given equation, and this is the equation. Then the second step, you then do the what? Derivative. And then this is what you're going to be obtaining. Then you're going to equate it to 0 so that you can be able to solve x. Then you're going to transpose this -4 x squared this side, and from there you divide with 4 both sides. Because we are looking for x, we have to get rid of this exponent 2. Then you put square root both sides, and then it's going to be plus or minus 10, square root of 10. And because we want this whole supposed to be positive, now the actual length is now positive. So x equals to square root of 10. The positive value of x, it will be that. It would be the maximum value. That is going to be the maximum value. Then you can see from even this equation, it's a cubic equation, right? And then it says the coefficient of x cubed there is -4/3. Then this is going to be the shape of the graph. So let me just try to draw the bigger shape so that you can be able to see that. I just want to explain something. How do we choose the maximum value there? This is going to be the shape of the graph of a cubic, right? If the coefficient of x cubed is negative, this is going to be the shape. And then we all know that at this turning point, the value of x it gives us what? Minimum value. And then up there, the value of x of the turning point, it gives us maximum value, right? Now we have obtained two values of x here, which is -1. So you can see if we draw a Cartesian plane like this, which one comes first? Which one is the minimum? Of course, it's going to be -1, negative square root of 10. It's going to come here, square root of 10. And then this one is what? Is the maximum, which is square root of 10 up there. So hence we have one, because the question was very clear that the value of x of the volume will be maximum. So now, hence we have selected this. We have to all right. Another scenario, it says an oil manufacturing company manufactures cylindrical shaped plastic containers. Each container must hold 275 milliliter of oil. That is the scenario. And the first question says, write h, the height of the container in terms of r. Remember what I said. What do you have from a scenario? What do you have? Then that is going to lead us to answer the first question and the second question and the last question. All right. Now we can see that we are having 275 milliliter of oil. Therefore, if that is the case, we can turn it into what? Into volume, because it's a liquid which is inside this cylindrical shape, and then we want that volume which is occupied by that oil. So then we'll have to convert this milliliter into a centimeter cube or cubic centimeter. One centimeter or cubic centimeter is equals to 1 milliliter. All right. Now, when we are having 75 milliliter, then we have to convert it. That is going to give us how much? It's going to give us the same 275 centimeter cubic or cubic centimeter. So that is the answer that we are having. Then, because now we are giving the volume, we're having the volume from the scenario. Then the first thing that we have to do, you write the volume for this cylindrical shape. And then we, fortunately, we have the formula for cylinder is there. Then just write the formula, that is the formula. From there, you substitute the values that we are having. And then because they said write h, now we're going to make h the subject. Then we're going to divide both sides with pi r squared. Then this is what we're going to be getting. That is the answer that we are having. And the second question says now, show that the surface area equals to 550 over r plus 2 pi r squared is the surface area of the container. We have to show that. Now let's see, you write the formula for surface area of a cylinder, and therefore we then substitute the values, but instead of h, you are no longer putting 8, but you're going to be substituting with 275 over pi r squared is what I did. Therefore, you simplify it, then it's going to give us this. It's going to give us that. This one. That's the correct answer that we're supposed to answer. The next question, we are having the same scenario, but now we have a new question that says determine the value of r, the radius of the container for which the minimum amount of the plastic will be used. The solution, and now let's see the solution. First, you write the surface area that we obtain from this first question. The second question, this is the surface area, remember. But now we want to derive this. But remember, when you have to derive, we don't want to see a fraction, because remember previously it was 550 over r. But now we have to write it in this manner so that we can be able to apply the rules of differentiation. So after we derived, this is what we're going to be having. And then you equate it to 0. But now, since we're in need of r, so we're going to take it back, make this exponent negative 2 to become positive. This is what we're having. Thereafter, because now we want the value of r, and then we have a fraction. To get rid of this fraction, we can multiply each term by the denominator of this fraction, which is r squared. So if you multiply r squared, then this is going to give us 4 pi r cubed equals to what? Now 550, because if you multiply this fraction with r squared, then it's going to cancel this one. Then we'll be left with 550. Therefore, then we divide both sides with 4 pi. This is what we did. And then now, because we are in need of r, we had to get rid of this exponent 3 by putting the cube root both sides. You can see that this the second step from last. And then after that, you just press your calculator, then it's going to give us, I think it gives us 3,9. So we can just round off the answer to become 4 centimeters. So this is the radius we are looking for. That is the radius that we are looking for. A drinking glass in the shape of a cylinder must hold 200 milliliter of liquid when full. Show that the height of the glass H can be expressed as this. Now from a scenario, you can see we are given milliliter, but we can convert it to volume. And then this is what we did. And then the volume that we have is 200 cubic centimeter. And that is the volume that we are having now. Because we are having the volume from the scenario, once we start writing or answering this question, we start writing the formula for the volume of a cylinder there. That is the volume. And from there you substitute, you make H the subject of the formula, and that is what we are having. This is what we are having. Second question, show that the total surface area of a class can be written as this. Then you write formula for surface area of the class. But now if you remember the previous one, there was 2 here. There was a 2 pi r squared. But now we don't have that 2. Why? It's because this is a class, right? And then now you can see that class up there or on top there is open. So there is nothing there. There's nothing. It's not the same as what a can, right? But it's just the glass, drinking glass, and it's open there. So meaning when you have to calculate the surface area of this top part and the bottom part, then we are not going to be including the top part because there's nothing there. It's open. We're only focusing on the bottom part. Hence we're having pi r squared, right? So that is the volume. And then from there, you just substitute the values. Because H, we have determined it from number 1 there, just substitute H, which is 200 over pi r squared. Then you try to simplify it. Then it gives us pi r squared plus 400 over r. So this is the answer for that. Then hence determine the volume. Let's see, I think that question you answered on the next slide, and let's see. All right, now it says hence determine the value of r for which the total surface area of a class is minimum. Now let me just underline, every time when they talk about minimum or maximum, you know that you take that equation you have created of surface area, then you're going to derive it. You're going to apply derivative, this one. But before we do derivative, remember we cannot derive highly scaled fraction like this one. Hence we had to write it in this way, which is 400 r to power negative 1. Then if that is the case, then we can be able to say as you can take it back, this one, so it's going to be 400 over r squared now, because it's no longer negative 1, but it's negative 2. Then because we want to solve r, then we have a fraction. To get rid of this fraction, you can multiply each term by r squared. So 0 times r squared is 0, and then this one multiplied by r squared, it's going to give us 2 pi r cubed minus 400. Of this exponent 3 by putting cube root both sides is what we did there. Then the answer is equals to 4 centimeter. So that is the value of r we are looking for, which is the total surface area of a class is minimum. The sides of the base of a rectangular cardboard shoe box are 3x, you can see 3x the length, and 2x respectively, which is the width. And the height is y centimeter. The box is open. The box is open on the top without the lid at this stage. All right. Now, if the total surface area of the box is this, total surface area of this, prove that. So you can see we're having what total surface area. So we're going to start writing the surface area formula for the box because we're given that from the scenario. And then let's see if that is the case. Yes, that is the case. Now you can see here that even the surface area of a box, it was supposed to be 2 width length plus 2h length plus 2hw. But because it was very clear from the scenario that the box is open on top, there is nothing on top there. Hence, we had to exclude that 2. All right. Hence, we exclude that 2. And then we then substitute the values that we have in there. And then from there, you're going to make a y, the subject of the formula there. Then you transpose, you divide, simplify. And this is what we are going to be getting. 20 over x minus 3x over 5. So that is the answer that we have to get. And then it says express the volume of the box in terms of x. We then substitute with this. We cannot put what y. We can put y because we have already determined the y in terms of x. And the question is very clear in terms of x. So we must have x over there. And then we simplify. So this is the answer that we are having. It's 120x minus 18 over 5x cubed. So that is the volume of the box in terms of x. All right, we are now having a new scenario. Let's study and see what to get from this one, what to get from this one. Let me see. I think this one we've already determined it. You can see this one is actually the same. Let me just see. The length is twice the width. The surface area of the box is 120. Okay. If you remember very well, there is a previous slide that we addressed this issue, this question. It was very, everything is the same. You remember we had to prove this one. So we're just going to skip this one because already we've got Now let's have this one. Say a farmer wants to make a rectangular chicken run using an existing wall as one side. He has 16 meters of wire fence. If the length of the chicken run is y, you can see the length and write the expression of the area. So they are looking for the area now, the expression of the area. But now before you can start answering the first question, you see what you have. You have to look from the scenario what you are having. So we are giving the distance, I mean the length of the fencing wire. And the length we know is what? Is the perimeter. Because the perimeter is the total length of all the sides. So if from this point around here until this one, the fence is 16 meter of wire, 16 meters. Therefore, that is the perimeter. You just add 1, 2, and 3. That is going to be the perimeter. Now you start writing the perimeter first. Let the width be x as it's shown in this picture here. You can see this is the x and this x, that is width. But now remember the perimeter of a rectangular box. The perimeter of a rectangular box, remember this is length, this is that. So the actual perimeter is equals to 2 length plus 2 width. Why 2 length? Because there is a length there and length on top there. There is a width this side and width this side. Hence we have 2, 2. But only L, which is 1 length. length will be facing this side. You're not going to put any y at this side or facing this side, because already it's a wall which is already existing that side, right? So there is no need to put a wire fencing that side. So we're only focusing on this side. And this will line or highlight the important information that will help you. Now, after writing the perimeter, you substitute 16, and then this what we are having. Length is y, then 2 width is x. Then you make y the subject of the formula there. That is what you want to be obtaining, 16 minus 2x. But now the question, we haven't answered the question. The question says you should write an expression for the area. So you write the area, length times breadth. That is the area. Then you substitute length, which is 16 minus 2x, and times x is what we are having. They find the dimension of the chicken run that will give the maximum area, So we're going to be using this one to obtain that. Then you do the derivative, you just apply the rules of differentiation, then you're going to equate it to 0, then you transpose negative 4x that side, and then from there you divide with 4, then the answer that we are getting is 4 meter. It's 4 meter. You can even check if you just put 4 this side, it will give you, it must give you 16. So this side is also 4. Now remember y, it is written in this way, you just put 4 there, and if we press a calculator, it's going to give us what, 8. Then 4 plus 8 plus 4 is 16. So we still have the same. So that's why we wanted to know the value of x. And the length. Now the rate of change. We are now under the rate of change. Let's see under the rate of change. Whenever you are dealing with the problem where one variable is changing, with respect to another, you will have to use the differentiation. You start deriving. Now let's get question scenario and see on how to apply this concept here. Now it says during an experiment, a learner must record the velocity of electronic toy car over a distance meter. T is the seconds that experiment has begun. The velocity of electronic toy car is given by this formula. Now the question determine the following questions. The initial velocity of the toy car, initial velocity. Now how do we answer that? This is the formula. But now where you see T is 0, because the car haven't started, so the time is still 0 there. So hence we the initial. So the time is 0. So we just press calculate and get 80 made there. Second question, the velocity of the car when time is 0.3 seconds. Let's see. So this is what we are having. Where you see T, you just substitute with 0.2. You press calculator, you get 0.76 meter per second. Respect to time when time is 1.2 seconds. Now you have to do the relative of the equation, of the given equation. Let's see, this is the equation. You start doing the derivative. After applying the rules of differentiation, you then have this. So where you see T, you are going to be substituting with 1.2, and then this is what you have, and then the answer is 1.6 meters per second. So that's how you should answer questions of rate of change. Rate of change. All right. Integration. We're going to be integrating. Integration. Number one, apply the standard form of the integral as converse of differentiation. Sometimes when they have to derive, they apply the rules of integration. So please, my dear learners, that know when the question it needs us to apply the differentiation rules, and then know when to apply the integration rules, so that we don't just lose marks unnecessarily. And then the other point says apply the rules of integration for the functions, and then apply the integration to determine the magnitude of an area included by a curve and the x-axis, or a curve, the x-axis, and coordinates x equals to a and x equals to b, where a and b are integers. But now today we are not going to be dealing or focusing on this one, where we have to determine the size or the magnitude of the area. We are not going to be that. We are going just to have a question under integration and apply the rules of integration, and then let's see on how do we do that. So that is the what we are going to be doing for under integration. And let's see. All right, we are having only two questions where we have to determine the integrals. Let's see on how do we do that. It says determine the following integrals. The first one, integral of -6 over x, now dx. So every time when we are dealing with this situation where denominator is x and then the exponent of that x is 1, listen attentively. If you are having this fraction, and then the denominator is x, and then that x exponent is 1, then that's where we're going to be introducing ln, right? Or sometimes they can give you in this manner, they can just write 6x to the power -1, right? So you can see, even if you can apply the rules of integration, you say +1, and you must also divide with it -1 plus 1. So you can see denominator is going to be 0. And then once the denominator is going to be 0, anything divided by 0 is undefined. So you can see it's not going to work that one. Hence, as I'm saying, if x is the denominator and the exponent of that x is 1, then you're going to introduce ln. Let's see on how do we introduce ln. Let's try to answer the first question. This one then is going to give us -6 ln x. It's very simple. -6 ln x plus c. For instance, if we had 2 over x, let me just write 2 over x integral dx. What is the answer? The answer is going to be 2 ln x. So that's how you should now answer this question. The second question, the integral of x minus 1 all squared. Now, if you remember the rules of differentiation, once you have a bracket, you have to get rid of that bracket first before you can start differentiating. The same applies with the integral. We cannot start integrating this. We first have to open the two bracket or that bracket, because we're going to say it's going to be a 2 bracket because of this exponent 2. So it's going to be x minus 1 into x minus 1. So we are going to apply a FOI, and then this what we are going to be obtaining, which is x squared minus 2x plus 1. So that is the quadratic that we obtain after we multiply the 2 bracket. Then from there you can apply the rules of differentiation. I mean, not differentiation per se, sorry, but the integration. We integrate it. Let's integrate it. Then it's going to give us x cubed over 3. Why? Because remember, you plus with 1, divide with that all the time. Plus 1, divide with it. So it's going to give us x cubed over 3x minus 2x squared over 2 plus x. So a constant was 1. Then if you take it back, it's going to be x plus c. Please don't forget to write c. Sometimes they can reward. They sometimes reward 1 mark just to write c. So let us make sure that we put c there. All right. That is the end of our lesson for today. Thank you very much. I hope everything that was discussed on this lesson is going to help you a lot for the coming final exam. And then now I can just leave you with this message that you see in your screen that says never give up. Today is hard, tomorrow will be worse, but today after tomorrow will be a sunshine. That is that. So thank you very much. Have a nice evening. Bye.